Welcome to The Explainer. Today we're going to pull back the curtain on one of the biggest, secrets in artificial intelligence. We're talking about the messy, complicated, and frankly, often ignored data problem that can doom a project before it even gets off the ground.
You've probably heard this old saying from computer science, right? Garbage in, garbage out. It means that the quality of what you get out is only as good as the quality of what you put in. Well, for modern AI, this isn't just some dusty old guideline. It is the absolute law.
So have you ever wondered why so many of these huge, ambitious AI projects, the ones that promise to change the world, just fizzle out? Well, the answer usually isn't the fancy algorithm. Nope, it's the data. And more specifically, it's a hidden problem called data debt.
Okay, so think of it just like financial debt. For decades now, organizations have been collecting tons of data across all these different disconnected systems. And over time, as companies merge and tech changes, it all just becomes this tangled mess. And just like financial debt, the interest on this data debt, the cost of untangling that mess, it just keeps growing and growing, putting a massive burden on the whole organization.
And look, this isn't just some small headache for the IT department. Data debt literally cripples a company's ability to do, anything smart with its data. It slows down big decisions, it opens up all kinds of security risks, it makes dealing with regulations a total nightmare, and it racks up huge costs. It really all boils down to one simple thing. You just can't build a futuristic AI on a foundation of crumbling, debt-ridden data.
So just how much of an AI project is actually about the data itself? Well, the answer, it might surprise you. It's 80%.
That's right, 80%. So for all the hype we hear about these genius algorithms, the vast majority of the real work, the time, the money, the sheer human effort in a typical AI project is spent just getting the data ready. And that right there, that reveals the real bottleneck, the true challenge of AI. It has always been about the data.
Okay, so if data is the problem, how do we fix it? Well, you start by paying down that data debt. And this is not a simple fix, let me tell you. It's a really challenging process, one we like to call the data gauntlet. And every single piece of data has to survive this gauntlet before it can ever be used to train an AI.
This whole thing is called data preparation. And in short, it's all the, let's be honest, unglamorous but absolutely essential work you have to do to turn messy, raw information into something a machine can actually understand. So let's walk through the steps.
So a typical data pipeline has 4 pretty critical stages. To make it through the gauntlet, your data has to be cleaned, it has to be transformed, sometimes it's multiplied, and then finally, it's split up.
First up, data cleaning. And yeah, this is basically the janitorial work of AI. You're hunting down duplicate entries, you're fixing typos, and you're stripping out all the useless noise. Things like stray pixels in an image. If you get this step wrong, you are literally building your AI on a foundation of garbage.
Okay, so after it's clean, the data needs to be transformed. The whole goal here is standardization. I mean, an AI can't learn anything useful if some of your data is in miles and the rest is in kilometers, right? Transformation makes sure everything is speaking the same language so it's all consistent and ready for the model.
Now here's a pretty clever trick. What do you do if you just don't have enough data? Well, you can multiply it. This technique, it's also called augmentation, basically lets you create new data from your old data. For example, you can take a single picture and generate dozens of new training examples just by rotating it, scaling it, or maybe shifting the colors around. All right, the final trial in our data gauntlet is data splitting. And this part is so critical. Here's why. You can't train an AI on your entire data set. That would be like giving a student the final exam questions before they even take the class. You have to hold some data back so you can test if the model actually learned something or if it just cheated by memorizing all the answers.
A pretty common way to do this is to split your data into 3 buckets. The biggest chunk, usually around 70%, that's for training the model. Then a smaller piece, maybe 10%, is for validation. This lets you kind of tune the model as it's learning. And that final 20%, that's the test data. And you keep that under lock and key for the final exam.
Each of these splits has a really important job. The training data, that's the textbook. The validation data, that's kind of like the pop quizzes along the way that keep the model on track. And the test data? Well, that's the final exam. It's the ultimate proof of whether your AI can actually perform in the real world.
But you know, even with perfectly cleaned, transformed, and split data, there's still one more hurdle. And this one, it's the most difficult, the most time-consuming, and honestly, the most human part of the entire process. It's often called the Achilles heel of modern AI.
We're talking about data labeling. See, for an AI to learn how to identify, say, cats in photos, a human being first has to go through thousands, maybe millions of photos and add a label that says, "Yep, that's a cat." This label is what provides the ground truth. It's the correct answer that the machine learns from.
And that leads to the real million-dollar question, doesn't it? If a machine can't learn without these pre-labeled examples, and you can't automate the labeling of new data, because hey, if you could, you wouldn't need the AI in the first place, then where on earth do you get all this labeled data from?
Well, the answer, unfortunately, is with great difficulty. There really is no magic bullet here. You could do it all yourself, but that takes forever. You could try to find a public dataset that somebody else has already labeled. You could get clever and trick your users into doing it for you. You know, like when a CAPTCHA asks you to identify all the traffic lights in a picture. Or what happens most commonly is you just have to pay for it. You hire a huge workforce through platforms like Amazon's Mechanical Turk or contract with these specialized data labeling companies.
So, after all that work, the cleaning, the transforming, the labeling, the splitting, you finally have a trained model. But is it any good? How do you know if your AI is actually smart?
This is where model validation comes in. This is the process of finally using that validation and test data we set aside earlier. We use it to see if the model can generalize. That is, can it apply what it learned to brand new data it has never, ever seen before? This is the true test of its intelligence.
Validation helps you catch two classic ways these models can fail. On one hand, you've got something called overfitting. This is where the model is like a student who just memorized the answers for the test. It does great on the data it's already seen, but it completely fails on anything new. On the other hand, there's underfitting. That's where the model is way too general and just didn't learn the important patterns at all.
So, the ultimate goal of this whole painstaking process is to find that perfect sweet spot. You don't want a model that just memorized everything, and you don't want one that learned nothing. You want a model that can genuinely generalize its knowledge to new unseen problems. And that final, untouched, holdout test data, that is the only thing that can truly prove you've done it.
Which, brings us right back to where we started. If 80% of all the effort that goes into creating artificial intelligence is actually just human-powered data cleaning, labeling, and preparation, well, it leaves you with a final thought, doesn't it? Is artificial intelligence really the right name for it? Thanks for joining us on The Explainer.